Cross-curricular approaches to mathematics and science. Cross-curricular teaching methods have been used for many years but continue to be scrutinised, falling in and out of fashion depending on the ever-changing education system. Currently, the new curriculum is again focused on this concept, emphasising the importance of cross-curricular links but not ruling out in some areas the importance of discrete subject teaching. Jim Rose's review of the primary curriculum in 2009 called for more cross-curricular links to be made, stating that they strengthen the learning throughout the different subjects and that making these links enriches and enlivens what is being taught. Furthermore, according to Jonathan Barnes in Cross-Curricular Learning 3-14, creative and cross-curricular developments are highly relevant approaches to 21st century learning. However, there are also many arguments that oppose this cross-curricular approach, encouraging subjects to be taught separately and independently. According to Taylor and Woolley in Values and Vision in Primary Education, 2013, cross-curricular activities became discredited because tenuous links were being made, which in fact hindered children's learning rather than enhancing it. Another concern was that topics within the curriculum may be repeated or missed out completely, reiterating the belief that some concepts need to be taught independently. So what are the advantages and disadvantages to cross-curricular learning, and is it more conducive to certain subjects? Cross-curricular teaching. It is perceived that maths and science are two subjects which have obvious cross-curricular links, and it is an area, unlike other subjects, where these cross-curricular connections come naturally, and it is both easy, if not inevitable, to link the two subjects. One major advantage to using cross-curricular teaching across maths and science is that science is able to give a context as to why certain things in mathematics need to be learnt, and therefore gives purpose and relevance to what is being taught. According to Robert Ward Penny, skills learned in mathematics enable progress and exploration in science, and scientific applications offer examples of mathematics in action, which can motivate learners of all ages. 2010. This reinforces the notion that elements of the two subjects need to be taught in conjunction in order to generate a greater and deeper understanding of some topics. Another significant argument is that when these subjects are taught completely separately, children can get a detached and singular view of the way to approach these areas and fail to see any relationship. One in particular area which provides the perfect opportunity for cross-curricular links to be used in maths and science is statistics. The new curriculum for mathematics explains that pupils need to be able to interpret and present data in a number of ways, in many contexts, and also be able to use a range of scales. Furthermore, it states that pupils must be able to draw graphs from their own inquiries in other subjects. This can be directly linked to the science curriculum focus, working scientifically, which says that pupils must make scientific inquiries, which include observing over time, pattern seeking, identifying, classifying and grouping, comparative and fair testing. This demonstrates that teaching these aspects as completely separate entities would make little sense, while teaching them together reinforces purpose, gives them a context, and anchors the understanding of how these skills are used, underpinning that maths and science are not isolated ideas but continually interlinked. According to Ofsted's 2011 report, Successful Science, more is needed to be done in primary schools to improve their science. The report specified that primary schools needed to focus on scientific inquiry and have a significant focus on developing skills. This can be seen to directly link to mathematical development, in that much of science inquiry depends on math skills. Stevens and Lenton explain that science relies upon an understanding of the underlying mathematics, 2013. This underlines the argument that cross-curricular links are useful and in some cases essential to support and develop learning possibilities in order to enhance progress in all subjects, but it must be in a way that the pupils do not lose subject-specific skills either. It is perceived that maths and science are, when looking at the new curriculum, an obvious focus is that mathematics should be developed throughout the different subjects. It states that teachers should develop pupils' numeracy and mathematical reasoning in all subjects so they understand and appreciate the importance of mathematics. Furthermore, the Ofsted report in 2010, Creative Approaches to Learning, highlights how good examples of creative primary schools use both independent subject teaching alongside cross-curricular activities to ensure valuable progress is made by pupils throughout the curriculum. One of the key findings reiterated that approaches developed in traditionally creative subjects such as the arts and English were often incorporated into other areas such as science and mathematics, which had a positive outcome across all the subjects. This highlights two complications with cross-curricular learning where maths and science are influenced by other subjects. One being that although beneficial, a concern is that subjects could lose their individual identity. Kelly states when highlighting these concerns that when planning a topic, the focus has been on the product rather than the process of learning, 2013. This leads to the second concern, which is that teachers, when planning these cross-curricular lessons, find it difficult to incorporate the connections whilst keeping the learning comprehensive and relevant. From a pedagogical perspective, it can be noted that cross-curricular teaching styles are both successful and current, but from an organisational standpoint, planning for these cross-curricular approach is far more complex. According to Goldston in 2004, Stepping Up to Science and Math and Exploring Natural Connections, she states that teachers often lack time to plan thoughtful connections in the curriculum, and connections are made as an afterthought. This is one key area which needs to be addressed in order to make sure that cross-curricular links are explicit and related to lesson outcomes. This means that when planning for these lessons, determining the objectives and progress which needs to be made needs to be outlined before the cross-curricular links are decided upon, rather than forcing weak links that are not beneficial to learning. As the new curriculum is more flexible, this will allow these cross-curricular activities to be integrated in a more considered and creative manner. In response, Ofsted have stated that there is no quick fix. The development of pupils' mathematics knowledge and skills and understanding through thematic or cross-curricular approaches requires medium and short-term planning of the highest quality. 2012. When looking at the new curriculum, an example plan for a cross-curricular maths and science lesson could use maths skills to underpin a scientific fair testing investigation. The investigation would incorporate many of the tasks outlined in the maths and science curriculum, as mentioned before. This would involve recording information, drawing graphs to present data, and analysing their results. This would achieve many maths and science curriculum expectations. The example on screen is a maths investigation for a Year 4 class, measuring the distance a marble would roll down a ramp from differing starting points, and then recording the findings. The class would be questioned as to the relevance of making it a fair test, would make predictions and calculate the average distance for each roll in order to plot a scatter graph using ICT in a following lesson. This is an example that would enable you to incorporate both scientific and mathematical skills, supporting how they underpin each other, and would allow you to go on to other elements from across the curriculum, such as ICT. It makes it obvious that separating the subjects in this case and teaching these skills in isolation would result in them losing their purpose and relevance. This adheres to the Plowden report in 1967, that children's learning does not fit into neat subject categories but continually interlinks. Furthermore, this approach promotes independent learning, and as Barnes states, experience is a starting point for learning, 2011. Responding to the previous cross-curricular issue that learning objectives may become lost and vague, the focus of this lesson is clearly highlighted and progress can be formatively assessed. This sort of lesson is an example of active learning through experimentation, thus not just passively receiving information, but being actively involved in order to create a greater understanding. In Enhancing Primary Science, Developing Effective Cross-Curricular Links, 2013, Kelly states that cross-curricular approaches to teaching and learning are informed by a constructivist view of learning. This is based on the proposition that learning is an active mental process in which connections are made between experience, prior knowledge, and new ideas to refine children's understanding of a topic. This stems from Dewey's notion and demonstrates how cross-curricular lessons can be highly beneficial as long as they are planned thoroughly and have embedded meaningful links. So what are the advantages and disadvantages of using cross-curricular links in maths and science? There are many benefits of doing maths and science together, as explored previously. An issue which needs to be considered is the implication that all children learn in different ways. Barnes explains that not all children respond positively to the same style of teaching or the same stimulus. It is therefore understood that cross-curricular approaches will not suit all children. This is a massive concern as it is imperative that all children make progress, which is why a discrete approach may sometimes be more appropriate. An example of when subject teaching may need to stay separate is when calculations are being taught in mathematics, as a cross-curricular approach could cause complications. The main positives of teaching maths and science together is the overlap of skills and ideas enables the subject to support and relate to one another, providing purpose, relevance and context. Pupils can understand how knowledge in these subjects interlinks and can perceive the relationship, and it simply gives a deeper understanding. Implications remain that when using this approach, lessons must maintain the depth of what is needed to be taught. Subjects mustn't lose their identities completely, and pupils should still be taught some methods discreetly. The new curriculum declares that teachers need to provide exciting and stimulating lessons to promote the development of pupils' knowledge, understanding, and skills as part of the wider school curriculum. Therefore, it is evident that a combination of cross-curricular teaching within maths and science, alongside teaching certain elements in a discrete method, is the most advantageous direction which will benefit all children's learning.